Hi there! Do you like making and keeping good memories with friends? I certainly do. So, I recently bought all of those nice white photo frames here, but then I realized that they all kind of look the same. And the question that came to my mind was, why not create a photo frame that is responsive to the image displayed in it and make it digital, of course? My name is Julia and I'm a student of Creative Media and Game Technologies at Saxion University of Applied Sciences. In this video, I'm presenting you AniFrame, the animated digital photo frame. My goal is to be able to upload a photograph to a website that automatically receives an animated frame depending on the dominant emotion and mood in the image. A bit like this. For the analysis of the dominant emotion and colors in the image, I decided to use the Google Cloud Vision API as it offers these two types of analyses. For the picture frames, I'm using anime.js, a JavaScript library for animating scalable vector graphics on the web. As an aspiring web designer, I really like how Anime allows for animated buttons, page transitions, or icons on a website. This is the AniFrame upload page. When I upload an image from my computer to the website, I want its dominant emotion and top 3 colors to be analyzed by the Google Cloud Vision API. While the upload takes place, the image can be sent to the API with a request of data to analyze using PHP or another compatible backend language. I chose PHP. The Google Cloud Vision API can analyze a variety of image attributes enabled through machine learning. I need data related to face detection and image properties. The API then returns a long array of data related to these two categories, including information about the emotion and colors in the image. But how to use it? First, I created an index.php page with a simple HTML form that uploads the image to the image display page, check.php. On the display page, I use the Google Cloud Vision client and my personal access token to the API, which is in a separate JSON file that is linked to the PHP script. Via the input name tag image from the upload form, the uploaded image can be recognized to create a variable that is then sent to the Google Cloud Vision API. Face detection and image property analysis are requested. The result is a multidimensional associative array. On the bottom of the face detection array for each face, values for the emotions can be easily found. For example, for face number 1, joy is very likely, the others are very unlikely. The dominant colors of the image can be found here. Their RGB values are returned separately. For the case of multiple faces with different emotions, I created an array to count the number of faces in the image. With a for loop, I can go through the face count array, extracting for each face its likelihood of joy, anger, and sadness, which allowed me to establish a counting scheme of the respective emotion intensities. Weighing the counts against each other results in one of 4 possible string values for the dominant emotion. If no dominant emotion can be determined, the result is neutral. The RGB values of the 3 most dominant colors in the image can be easily filtered out from the subarray info by following the associative nesting. The animated photo frames are based on these 4 images, representing joy, anger, sadness, and neutrality. Since my example image in this video is joyful, let's focus on the code of joy first. To begin with, I learned JavaScript and anime.js. My first animation iteration consisted of a simple animation based on manually set values for the dominant emotions and colors. With an if statement, I identified the manually set dominant mood and picked the corresponding SVGs and animations. The dominant emotion is made accessible to the document object model by echoing it out between PHP tags. I specified that the joy animation is a line drawing with a stroke offset of 0 and other parameters like the delay, the easing, and the visibility parameters. Then, I added a secondary animation to make the image display even more interactive. Across the 4 possible mood-based frames, I use all 3 main SVG animations: morphing, motion path, and line drawing. Let's put the results from the API and the animations together and have the animations based on the results from face detection and color recognition. These are the final results for 4 images with different emotions and colors.